Okay, so we're looking at synthetic division for the first time. Add polynomial. But it's much shorter, so I'm going to say another way, shorter, hooray, to divide polynomials. Its downside, though, is that you can only use it when divisor is in the form x plus or minus some number. I'll just do x plus n, where n is some integer. Now, I will say, just for YouTube land, there actually is a way to divide it if x has a coefficient, but it makes it a lot worse, and everyone forgets about it. So yes, although there is another way to do this, if you have a binomial with a coefficient on the x, I'm not recommending that you do it because it's a disaster, so I'm not going to talk about it. But don't think that I'm a moron and I don't know. I do know, but it's a mess. So, any Hoosers, we're going to have x plus or minus some number. So if we take a look at our example sheet here. So if we flip it over and you look at number 15, for example. So I'll just rewrite number 15 on this paper here. So we're going to be doing k to the third plus 11k squared plus 16k plus 65. And we're going to divide all of that by k plus 10. Okay? They're using k's instead of x's. Whatever, that's not really a big deal. Okay? So here's what's a little bit weird, though. You want to think of this, right? If this is how I think of them. If this were a factor, so let's say I'm solving a quadratic, right? And you know when you get your factors and then you get the zero from it, right? So if that's my factor, k plus 10, what's the zero that actually comes out of that? Remember when you're solving quadratics, if you had like k plus 10 and k plus 1, your answers aren't really k plus 10 and k plus 1. It's really just, right, it's negative 10 and negative 1. Does that make any sense? It does? Oh, wow, okay. So here's what you need to do. You're going to synthetically plug in whatever the zero is that comes from that. So in this case, it's a negative 10. Are you with me so far? Is everybody okay? Yeah, okay. So we will plug in the zero that comes from this factor. In this case, it's negative 10. Okay? For synthetic division, you still want to make sure that you are in standard form, both of them, right? And just like before, I have to put in a zero placeholder if any of my degrees are skipped over. So I'm starting with k to the third. So I have 3, 2, 1, none. So I'm all set. If I was missing any of them, I would have to plug in a zero placeholder, just like with long division. Okay, so here's what you do. I'm going to scoot it over here. All right, first thing on your top line, you're going to write all the coefficients of your dividend. So the coefficients are just the numbers out in front. So I'm going to write 1, 11, 16, and 65. If any of them were negative, I would make sure that I would keep them negative. In this case, they're all positive, though, so I just leave it like that. So I don't have any more room, so I'll just write over here. 1, 11, 16, 65. So everybody sees where I got those numbers from? Okay, so just if you needed a zero placeholder, you would put it in and one of those numbers would just be a zero. If any of them were negative, you keep the negative sign with it. Okay? And then everybody does theirs a little bit different. I like to make kind of like this big L shape. And then whatever number I'm plugging in, I put out here to the left, -10. Okay, so here's your steps. Once you get the hang of them, it's actually really fun. So the first number, whatever it is, that one just gets brought down immediately. So that one's just a 1. And then here's your process. You're going to multiply these two numbers together and write its answer underneath the next one. So -10 times 1 is -10. And then I'm just going to add these two together. So 11 plus -10, that's just a +1. And then I just keep repeating that process. So I'll do -10 times 1, write its answer underneath, add these two together. This time I come out with a 6. Multiply these two numbers together. And then add those two together. And I'm there. Great, Miss Savia. What the heck am I going to do with these numbers? Well, this is what's so cool. So once I'm done, does everybody see the process? Okay, once I'm done, here's what's so neat. This last number right here is always your remainder. So it is possible that you get 0 as a remainder, and then it just means that it divided in evenly. This time it didn't. I have a remainder of 5. This is just your constant. So that number just stays as it is. And then these are the coefficients going forward. So this is the coefficient of your x to the first term, and this is your coefficient of your x squared term. And if I had more, I would just keep going. So watch how I write the final answer. So I would just write 1x squared, but the coefficient's a 1, you don't have to write it, right? So it's just x squared plus 1x, or just x, plus 6, plus my remainder over what I originally was dividing by, which was k. Oh, I'm sorry, these are supposed to be k's, not x's. Whatever. I was originally dividing by x plus 10, but really k is, ugh. I hate when they don't use the variable that I use. So it's always over what you were originally dividing by. Yes. Because you have to plug in what the 0 would be from that factor. Yep. So you're always going to plug in the opposite of what you see there. So if you had done this with long division, you would have gotten the exact same answer. Right. Once you get fast at synthetic, I mean, it takes you 2 seconds. Obviously, the first time it takes us a little while because I have to go through it. But that's pretty much it. The hardest part for kids is usually figuring out how to write this final answer. Okay, so let's try another one and see if we can work our way through it.